Yeah, and again, I've spoken to some of you now, guys. Look, some of you are heading over to your private schools next year, and I'm trying to make you the best student I possibly can, trying to show you that it's better to go educated than to be average. All right, and some of you guys just sit. All right, some of you were doing good, now you're not doing good. All right, and it's just simply I've tried to look at you and tell you, come on, you're daydreaming. All right, you're not paying attention. All right. And some of you went from, you know, not understanding and now you're making A's. All right. It's totally possible. Everyone in here now is in the same exact position. All right. It's a new topic. All right. No one knows in here how to do this. All right. So everybody's in the same exact place. All right. So I'm going to try to explain to you how to undo the distributed property, which we call factoring. All right. So I'd like everybody to look up on the board for just a quick second. All right. And then I'll pass out the worksheet and you should be able to zip right through it. All right. If I say to you, for example, 3x, come on, you don't have to write any of this down. I just want you thinking. You don't have to write anything down. I'd much rather you just listen. If I say 3x times 2x minus 5, if I multiply that, that's what? 6x squared minus 15x. Everybody agree with that? All right. So now the key is that we are taking this, right? That's what we started with. And we ended up with this. Now what I'm telling you is I'm asking you this. All right. I'm saying if 6x squared minus 15x is your binomial, I need you to undo the distributed property. I need you to undo the distributed property. Now, when you distributed, you agree you multiplied the numbers, and what did you do to the exponents? You added the exponents. Come on now. I multiplied the numbers and added the exponents. So if I'm going backwards, instead of multiplying, I'm going to be doing what? Dividing. Instead of adding, I'm going to be what? Look, guys, I don't understand the difficulty of this. I really don't. All right. I'm just working backwards. And the tests were okay. All right. Most of you know how to multiply. The hard part is going backwards. Put your hands down. I'm not done. All right. So multiplying, you multiply numbers and add exponents. So if we go the reverse, we divide numbers and subtract exponents. To me, that is logical. For some of you, it's not. All right. So we have to do extra problems. All right. Now, the question is, if I'm at, and let's say I don't know over here, I don't know that's my answer, but I'm starting here. You say to yourself, what is common? What is common with 3 and 15? 3. They're both divisible by 3. Now, we're doing the GCF. That's the greatest common factor. The greatest common factor. Is everybody with me? So, number-wise, what's the largest number that goes into 6 and 15? 3. Now, how many x's are here? 2. How many x's are here? How many are common then? Common means are in both. There is 1. So that's how I got the 3x. Notice here, that is the GCF. I just found the GCF. It's what again? 3x. Now, working backwards, what do we do to numbers? Divide them. So I look at the 6 and I divide it by 3. What's 6 divided by 3? 2. There were 2 x's. I pulled out an x. So there's how many x's left? 1. What's negative 15 divided by positive 3? Negative 5. I don't understand the difficulty. And that's how easy it is to factor. All right. So we're going to come back up here now. Let's see how great I did. All right, for number 1.
So would the greatest common factor be 10x?
Close. 10 doesn't go into 8.
Oh, 8.
But you thought 8. You're right. Let him alone, please. He's giving it a shot. 8. What else is common? Shh. I'm asking Davis. X. There's a common X. Now, I used to teach my kids buckets. Here's a bucket. Here's a bucket. What's in this bucket? 8 times 1 and X times X. What's in this bucket? 8 times 10 times X. What's common in each bucket? There's a common 8. And there's a common what? X. That's how I used to teach it. All right, then eventually your brain will say, well, I'm just going to find the GCF, then I'm going to divide the numbers and subtract the exponents. That's what you're supposed to know. All right, so I pull out an X. So what's left behind?
1x.
1x. I like the way he said 1x. The reason it's a 1 is because 8 divided by 8 is what? 1. You don't have to put it there. I know. I'm showing it you for your own benefit. I know 8 divided by 8 is 1. Now, what's negative 80 or 80 divided by 8? There you have it. Are there any x's left behind? No. So it's 8x times parentheses x minus 10. All right. Number 3, Anthony, what's common?
3 or 6.
6, does that go into 9? Is there something bigger? Shh, nope, let him think.
9.
9. You always take the G, greatest. 9 is the greatest. Now what else? There's an X. So what's left behind? Shh.
Minus 4.
That's how easy. That's it. All right. Zane, what's common? Does 11 go into 165? The answer is yes. 11 times 15 is 165. So I'll help you out with that. So now what's common? 11 what? 11x. What's left behind? Beautiful. Molly, you're up. What's common? What's left?
1 negative 9.
Sydney, does 9 go into 153? Yes, it does. 1 plus 5 plus 3 is 9. All right, so what's common? Shh. 9, what else? 9a. What's left behind?
Oh, 1.
And then,
Minus.
of course, 17 times 9 is 153. All right, anybody have any questions with that? What? Yes, of course. 1 is the same. I'm doing that just because I'm emphasizing I divided. All right, next. What's common? Jackson. 6. What else? Well, today that's a V. All right. Now what's left? 1V. 96 divided by 6. You just do that on your calculator. I don't care. All right, here we go. Listen to this one. 13, go. Finley.
So 4 times 1x.
You don't have to say times 1x. It's just 4x. Parentheses. Now what? You pulled out the X. Huh, what do you mean? Shh.
Oh, it's Y.
Do you know why there's no X there? Because, yeah, that's exactly right. So now, look, the other thing is I almost feel like making everybody do is just redistribute 4x times x. That's 4x squared. 4x times 8y. That's 32xy. Now, did I do it correctly? Yes, because this answer is this. You're factoring out. So it's you should make 100 on the test because you can just multiply everything out. You understand me now? All right, multiply numbers, divide, or when you undo this or when you factor, you divide numbers and subtract exponents. AJ, what's common on 15? Just be A, thank you. And then no,
Oh, wait, 9B.
9B, perfect. You understand that, right? That's not hard. All right, over here, what's common? How many? 3. Come on now. There are 3 X's in common. Perfect. Perfect. If you don't know, speak up. What?
You get the X for Q.
Because how many X's here? How many here? How many are in common? How many are in both sets? 3. Do you hear me? All right, at the top, go. What's common? Miss Wood, go. 5 what? Where's the P over here? 5Q. What's left?
Plus 2.
Perfect. P squared plus 2. All right, next, 21. What's common? Nope, just 5. We only factor out a negative if the leading coefficient is negative. All right. So don't factor out a 5 because you see this is negative. It's just what's common with 35 and 5. I'm listening. Is there a common B? Yeah, there is a common B. Come on, this is a little bit harder. So there's a common 5AB in each bucket. So what's left? What do I do with the numbers? Yes, what's 35 divided by 5? 7. Good. And then, yes, there you have it. 7AB minus 1. Divide the numbers. 5 divided by 5 is 1. All right. There's never going to be just a 0. All right, here we go. Next. What's common? Oh, you got the hard one because there's 3 of them. Don't be fooled. What's common? 2. What else? You're amazing. That's how easy. GCF, 2W, parentheses, what? Divide numbers. 3 to the what power? What do you do with exponents? Subtract. You're going backwards, so you're going to subtract. There were 4. You pulled 1 out. How many are left? Beautiful. Now what's next? You're awesome. Now what? Tell me what's 2 divided by 2? How many W's are here? How many did you pull out? How many are left? That's correct. All right, come on. It's just a pattern. Divide numbers, subtract exponents. Divide numbers, subtract exponents. Divide numbers, subtract exponents. GCF, GCF, GCF. Next. Now, listen to me. Everybody needs to pay attention. When the leading coefficient is negative, you pull out the negative. All right, so you got a hard one. So what's common with -3, 15, and 6? Good, -3. And then how many p's are common? Nope. 1. Common means they're in all of the buckets. Although there are 4 here, and there are 2 here, and 1 here, there's only what? 1 common. All right, now let's see if you can get this right. You're awesome. Now I'm going to put a 1 here just because I want to recognize that we divided. Go ahead. You're awesome. That is correct. What?
So would it all just be, if it's common, would it every time, would it just be like the lowest number?
Yes. You're taking the least amount from each bucket, or you're taking the greatest amount possible from each bucket. But you have to pull the same amount from each bucket. You with me? All right. Here we go. Number 2, go. Wyatt. 8 what? Good. What's 72 divided by 8? How many x's are here? How many did you pull out? So how many x's are left? That's right. That's your answer. Read next.
Would be 4 P, and then times just P minus 7,
Not 7p, just what?
just
Just 7. Davis, go.
would it be the 6 P, 1 P, and then minus 12?
Because 72 divided by 6 is 12. Next. Come on. Yeah, you're not paying attention.
30 times, 8 minus, 20, 8, or just 20.
Next.
Okay. So it'd be, so 4K. 1, okay. And then 14.
Molly.
6 and minus 14.
Okay. Doesn't matter. What?
Do you essentially just do like a 1?
Yeah, I put a 1 there. Yeah. Just so you know, you divided. Okay. 14, go.
4 and A.
4n and a.
And then
You said that.
5,
I think you said that. Go.
1 and N. And
No,
then
not n. You
3, 1.
pulled the n out.
Oh,
Come on now, everybody's got to listen on this one. Do you agree? And there were 2 a's. I pulled 1 out, so there's 1 left.
5.
Yes. There you have it. All right, what's common here? Very nice.
Maybe X
Good.
plus 3. Wow.
You're awesome. That's correct. Finley, go. 18.
2. 1M plus 3M.
Read.
Would be 5. And then times
Whoa. 5p what? Isn't there a Q here? Isn't there a Q here? Do you agree? 5pq, right? There's a P and a Q in both. What's left? 10 divided by 5.
2.
2 what? AJ, go. 12 and 8. Come on, what's common with 12 and 8? 4. How many A's in the first bucket?
2, so it'd be 4A
Good.
times A.
No, I'm asking you, how many A's were common? You said an A. Now check out the B's. How many B's were common? There's 3 here. How many over here? So how many are common? Now, common means they're in both. Yeah, you see what I'm saying? It has to be in both. There's 3 in the first one, but only 1 in the second one. So there's only 1 B common. How many C's are common? None. What about D's? How many here? How many here? How many common? There you go. Come on, guys. All right, you guys are being distracted over there, and I, I can point out to something. Good job. Keep going.
Plus 2. B squared.
How many B's are in this one?
Oh, 1.
How many did I pull out?
Be 2. Just be 2B.
Yes, sir. Very nice. That's it. That's all it is. What's common? And remove it from the bucket. That's it. Listen to the next one. Go. Two are what? Yep. Perfect. Next. What is funny?
5, 8, and then 10, and then parentheses, 8, 2, minus 4, 8, plus 20, nothing.
That's how easy that is. All right. That's how easy. What? Good for you. Come on. I mean it when I say get busy.
It's 5 up from hour and 4. Because aren't you dividing?
5 divided by 5 today is what? if you notice, every time I did what's common, I did 5 divided by 5, 20 divided by 5, 100 divided by 5. That's what those numbers are. And then I subtracted the exponents.
But, where'd you see that first one?
This,
The H2.
because there are how many H's here? And how many did I pull out?
Oh,
Wow.